So I am doing number 13, and this is a 70 kilogram base runner begin to slide into second base when he is moving at a speed of 4 meters per second. The coefficient of friction between his clothes and earth is 0.70. He slides so that his speed is 0 just as he reaches the base, and they want you to find mechanical energy lost and how far he slides. So if you see here, he moves this way, but there's no force coming this way, but there is friction. And we're given mass, initial velocity, the mu coefficient, the friction coefficient, and final velocity. So the first thing we want to do is find A, how much energy is lost during this. So if you see here, work is equal to the change of energy. So there's no mgh, so there's no potential energy, so it's just kinetic energy. So 1/2 mv squared of the final minus 1/2 mv squared of the initial is equal to work. And the work is equal to negative 1/2 mv squared initial because there is no final since the velocity is 0. And then you're just going to plug everything in. Then you'll find out that you have negative 560 joules lost. So now you want to find how far he slid. So that will be represented by work is equal to the friction force times displacement times cosine 180. And you get the equation work is equal to friction force cosine 180. Work over friction force cosine 180 is displacement. And to find the normal force, you're going to do your sum of forces and the y. And you'll find out it's 686 newtons. So from there, you just plug in your givens. So the friction coefficient, the normal force, and then the cosine 180, because it's horizontal. And you get 1.66, but it rounds to 1.2 meters. That's number 13.